Hi, and thanks for this opportunity to share with you just why we are natural at some skills and not natural at others. I'm Winford Dorr, and I've had the privilege of working with many wonderful researchers for the last 15 years, focusing on just this subject. So, have you ever wondered, if you get a class of 10 children or 10 people with the same teacher or coach, and they all learn and practice to the same extent, 9 get it perfectly and 1 won't. Why? Now, typically, we become reasonably good at about 95% of all our skills and actions that we do repeatedly. They become pretty automatic. They've been fine-tuned by the cerebellum in the brain here, so we don't have to think about them when we do them. And as scientists would say, they are skills that are done outside of our voluntary conscious awareness. They're skills and actions for which the brain has developed a perfect model, hardwired so you can carry out those things with precision time after time. When we start to learn a new skill, it's usually because we're doing something repetitively and the brain says, I might as well write a program for this. Now, the same is true whether it's a sporting skill or a social skill or any cognitive function. First of all, when we do something for the first time, when we start repeating it, we're doing it in our thinking brain. So, do you remember learning to ride a bike for the first time? You knew what you were supposed to do. You had to balance, you had to lean over when you turn corners, you have to pedal and you have to brake. But whilst you were having to think about it, the processing in your thinking brain was so slow and so unreliable that before you'd process what to do next, you'd fallen off the bike. Now, assuming you didn't give up and you kept practicing riding, eventually the brain created those dedicated wiring looms that did the balancing, that does the steering for you, does the pedaling automatically, and you no longer have to think about it, because the instructions to your body were instantaneous and you can ride. That is learning. That's what's happening when you're developing the internal model or the computer program to carry out those skills and actions. Then when you're doing it, every mistake you make sends a message to another file in the cerebellum, the inverse model. And then your brain has got the internal model and the inverse model, what should happen, what actually happens, those are your experience files, and then it uses one to fine-tune the model so that that model becomes more accurate and more consistent. And eventually, you've got a reasonably reliable automatic program for riding your bike. And the same is true for millions of sporting skills, social skills, and other skills that we use every day. And you hardly ever have to think about them when you do them. From then on, of course, even if you haven't ridden your bike for years, whenever you take it out of the shed, pump up the tires and jump on, your brain looks up the internal model, uses the dedicated connections that makes riding automatic and effortless. It's a lasting skill. Now tell me, what's 9 times 7? Well, what I've been describing is actually same for all your thinking skills too. And if your 7 times table is fine-tuned, then you wouldn't have had to thought about that. You'd have known the answer was instantly 63 without having to think about it. Now, our brains are usually able to acquire skills like this, hardwire them, produce models for them, for about 95% of the skills we use regularly, whether that's for sport, for work, just cognitive or social skills. We create internal models and we can do them reasonably well without thinking about them. And every time the outcome doesn't tie up with the internal model, then the brain, in fact, the cerebellar olivary system, detects the error, generates an error signal, and that internal model is adjusted and improved to reduce the chances of making that mistake again. But what about the other 5% that we never get really good at, that we never become natural at? These are the things, the actions, the skills that the cerebellum has never been able to create models or programs for. The reason that this happens is that the part of the cerebellum responsible for making programs for that type of skill is itself not developed enough. It's a bit like having one computer programmer for each type of skill, and the good programmers find the bugs in the program, sort them out, create the perfect program for you to use. The poor programmers never finish off the coding properly, you're always left with the bugs, so that skill never becomes consistent. You never become natural at it. So those 5% of skills your brain can't learn, all because the programmer allocated to that type of skill or action is useless or lazy or both. The annoying thing is that even for the 5% of skills that you have that never become natural, you do in fact build up the internal and inverse models to an extent. So you are developing your experience files, even if you're trying to do it and you're not doing it very well, you're failing. But the trouble is, for those, the brain is never able to make that final version of the model that you can use. So let's take some typical examples of what happens when a skill doesn't develop dedicated wiring and become natural. And are any of these representative of you? First of all, let's think about listening. What is poor concentration? Well, when the process of turning what we hear into what we fully understand is not fully developed, and this is common, it probably applies to 1 in 5 people, it's because the internal model for that skill, for that action, is not itself clear. And it's a very slow process. So by the time you understood what is being said in one sentence, the speaker is by now halfway through the next sentence and you're having to play catch up. This is very often the reason for poor concentration. What about reading? Key to reading is the control of movement of the eyes, and it's called oculomotor control. As many as 1 in 4 people have this to some extent. Without the brain having a model for this skill, so it does it instantaneously and automatically, your working memory has to control the way that your eyes track. Therefore, this process is slow, and in fact so slow that your eyes jump around trying to keep up with your reading. And when you jump, you see the letters in the wrong order. And people with this issue usually struggle with spelling, and it's no wonder why. When you're reading, it actually gets worse than that, because after you have struggled to slowly read a word and work out what it is, you then need to store it so you can read the rest of the words in the sentence. And where do you store things? In your memory. And that memory is already busy, it's nearly full, because it's having to process the skill of eye tracking, because there's no hard wiring for that. By the time you've got to the end of the sentence, you've completely forgotten what the first words were. You had nowhere to store them. So whilst you might be reading them incorrectly individually, you don't understand the sentence, you haven't comprehended it, and so you have to read it again and again, and after a while you're exhausted and give up. So that's reading. What about balance and coordination? The ability to move our body, our limbs, perfectly coordinated, smoothly, consistently, all of the time. It's skills that's crucial for sport, but they're also really useful in everyday life if you don't want to be clumsy. We've all watched a child or even an adult that couldn't catch a ball, and it's funny for some. It's not for them, of course, and they try hard and they still can't catch. Now, for every sporting action, there's countless internal models developed. Some would develop brilliantly, some developed a bit, some not at all. The better the internal model, the more accurate and consistent the skill will be, and the less you have to think about it. And whatever you're natural at, you've actually got a great internal model for. Is this making sense? Well, there's one important further consequence of not having good internal models for the things we're doing regularly. Because as we know, when our actions don't have an internal model, our working memory has to be used to work out what to do and make it happen. But we only have limited working memory space. It's a bit like the memory in your computer. And when it's full, it's full. And we are likely to go into overload, and that's not a pretty sight. So running out of working memory means we have no space to do the things that we need to do, no space to control our emotions. It can cause mood swings, anger, frustration. May mean poor organisational skills too. We haven't got the capacity to work out what to do and how to organise it. It means we have poor short-term memory and so on. The consequences are huge. Now, some skills have no model at all, can't create it. Others will have a reasonable model and some will have a perfect model. And it's these that we're natural at. So I'm hoping that all of this is beginning to help us here understand people a lot better, when we now realise that people aren't making a choice when it comes to what they're natural at or not, what they find easy to learn, or not. But the big question is, what can we do about it? Well, in recent years there's come about lots of scientific evidence that specific types of stimulatory exercise can be used to develop the cerebellum. For instance, what they call sensory motor balance training works on the vestibular system and has been proven to increase the grey matter in our cerebellum. How wonderful is that? The challenge, of course, has been that everybody's brain is different, totally different. So everybody's brain needs different levels and different types of stimulation to effectively develop it. Well, using research that started in leading universities around the world, withZing has worked hard to continue this research, to find a way of assessing each brain, and then to produce a personalised course of sensory motor stimulation to develop the cerebellum where it's needed. The course that withZing's developed monitors the progress, provides feedback about how each skill is improving, and makes crucial adjustments to optimise the course along the way. The whole thing actually only takes 5 to 10 minutes a day, and the initial course is only 6 months. During that, the cerebellum is developing more grey matter in the right places and now able to make internal models for the types of skill that you weren't natural at before. And even those skills that had reasonable models before, so you were reasonably good at them, often acquire more precise models or programs. So those skills now become even more fine-tuned, more consistent and more natural. And if you had any skills for which there were no models previously, you were just not a natural at them, often your cerebellum is now able to use the experience files that you had accumulated by those failed attempts to practice those skills. And quickly you're able to develop models for the first time. That is a quite remarkable experience. But when it does happen, please remember there are 3 steps to learning: being taught what to do, doing lots of practice, and finally making the brain capable of learning that type of skill. withZing has actually only assisted with that last but vital element. So now, for the first time, you don't have to accept that you have a few skills that you are not natural at. You have the option to develop your brain and change that. So if you're fascinated by this research and want to find out more about how we achieved it, please have a look at withZing.com. Thank you.